Okay, so let's go to page 4 of our note packet. So today we're talking about adding and subtracting polynomials. Today's lesson is going to be about adding and subtracting polynomials. So a couple of things that you need to know when you add polynomials, add or subtract, you want to look to make sure that they're like terms, right? You have to make sure that you have like terms. And we said yesterday that like terms have the same variable with what? Yep, with the same exponent. So in case you forgot what a like term is, I've just reminded you. Same variable with the same exponent. When adding or subtracting like terms, adding or subtracting polynomials, you can only add or subtract the coefficients. The exponents don't change, right? You're just adding or subtracting the numbers attached to the variable, the coefficients. We don't change the exponents. You can use either the horizontal format or the vertical format. And I tried to make sure that I did our notes kind of back and forth different ways so you could see them both. And then you always have to make sure that you write your answer in standard form. You always want to make sure that you write your final answer in standard form. Okay. The other thing is when you subtract polynomials, it says that you change subtraction to addition. Well, remember that when you subtract, you have a negative outside of a parenthesis, right? When we subtract, we have a negative outside of a parenthesis. So we're going to distribute that negative or that minus sign through the entire parenthesis grouping. That's how we remember to make everything negative. If we don't do that, we typically only subtract the first term and then the rest of them we add together. Okay. So let's look at this first one. Example number 1 says to simplify, what am I asked to do to both of those terms? What am I doing to those polynomials? Am I adding or subtracting? Yeah, I'm adding. This says that we're going to add them together. So I'm going to do this one vertically. So when I use the vertical method, I want to make sure that I try to write my first polynomial in standard form. Remember, we said that we try to put the variables in ABC order. So I have 5f plus g minus 2. And to that, I'm going to add, so I'm adding this polynomial to it. I need to line up, when I stack these together, I need to line up my like terms. So I have a negative 2f term. I don't have a g term at all, so I just skip that spot. But I do have a constant. It's positive 3. And then I'm just going to add them up vertically. Let's see, negative 1 plus 3, or sorry, negative 2 plus 3 is positive 1. Because it's a positive, I'm going to put a plus in front of it. There's nothing for me to add this g to, so it just comes straight down. And it's positive, so I'm going to put a plus in front of it. And let's see, 5 minus 2 is 3, 3f. So this is what the vertical method looks like. And this is in standard form. 3f plus g plus 1. Questions about that? Okay, let's look at our next one. Our next one is what kind of a problem? It's a subtraction problem, right? This has a subtraction sign. So the direction said we're going to distribute this negative throughout the entire parenthesis. So I rewrite the first parenthesis. I don't change anything. I have 4x. I don't know why that's doing that. I have 4x cubed minus 3x plus 10x squared minus, let's see, a negative times a positive 8x is a negative or minus 8x squared. A negative times a positive 2x is a negative 2x. And this negative distributed all the way through to this negative, let's see, a negative times a negative makes this a positive x cubed. Now I have to kind of identify my like terms. Let's see, I have a negative 4x cubed and a positive 1x cubed. What is negative 4 plus 1? Negative 3. So this is negative 3x cubed. Now I'm going to go to I'm going to try to put it in standard form as I do this. So the next thing I'm going to do is I'm going to look at my x squared terms. Let's see, I have a positive 10x squared, and I have a negative 8x squared. That's going to be positive 2x squared, right? So if it's positive, we got to put that plus in front of it. I noticed yesterday sometimes you guys were just kind of smushing the signs, like you were forgetting the signs. Remember, this is a polynomial. The terms are joined by addition or subtraction. So if it's positive, you have to put a plus in front of it. Our last one are the x terms. Let's see, I have a negative 3x and a negative 2x. If the signs are the same, I add them together and keep the sign. This becomes what? Negative 5x. And now I have subtracted these two polynomials and I've written my answer in standard form. I've subtracted the two polynomials and I've written my answer in standard form. Okay, Travis, I need you to pick up your pencil and start taking some notes with us. Number three. Okay, so what do I see here? What's going on? So what do I have to do when I have a subtraction? What do I do with that minus sign outside of the parenthesis? Yeah, I'm going to distribute it. So my first term doesn't change, my first polynomial. So let's see, 2x squared minus 3xy plus 5y squared. A negative times a positive 4x squared gives me a negative 4x squared. A negative times a negative 3xy gives me a positive 3xy. And a negative times a negative gives me a positive 2y squared. All of these terms, I don't know if you guys noticed, but all of these are degree 2. This is degree 2. 1 plus 1 gives me degree 2 and degree 2. So when I say you want to put them in ABC order, x comes before y. And then in the second grouping, x is before y, and then y is the last term. That's how that kind of works. It takes a while to get used to, but that's what we want ours to look like. We want the x, then the xy term, and then the y term. So let's see. I have a 2x squared and a negative 4x squared. What's 2 minus 4? 2 minus 4 is, so I have a negative 2x squared. Now I'm going to look at my negative 3xy term and my positive 3xy term. What is negative 3xy and positive 3xy? It's 0. Those cancel each other out. They cancel each other out. Are you following along with us, Carla? Okay. Those cancel each other out. The last thing is a positive 5y squared and a positive 2y squared. What is 5 plus 2? Positive 7y squared. And this is in standard form. Feel good about that? Okay. Next one. We're going to do this one vertically. What do we have going on here? We have an addition problem and a subtraction problem. So we have to take this on the subtraction side and distribute it through. All right. So I'm going to slide a little bit over to the right because I'm going to do this vertically. And I'm going to start with this one because I have to change it, right? So a negative times 3x squared is a negative 3x squared. A negative times a positive x is a negative x. And a negative times a positive 5 is a negative 5. Hayden, you're not going to learn a whole lot if you keep your eyes closed. Okay. Next, I'm going to go to that first term. I'm adding. So I'm going to add 2x squared. I'm going to line that up right below it, right below the 3x squared. My first term has a negative 6x, my first polynomial, negative 6x. And then a minus 2. That negative 2 is my constant. My second polynomial only has 2 terms. It has an x squared and a 4x. The x squared is going to go right below the negative 3x squared and the 2x squared. And if you need to, if it helps you to think about it, put a 1 in front of that because it's 1x squared. And then I have this positive 4x. I don't have a constant term there. I don't have a constant term, but we're adding all of these together, right? So what is negative 5 and negative 2 when I add those together, Uriah? Negative 5 and negative 2 give me, perfect. Caden, what is negative 1x, negative 6x, and positive 4x turn out to be? -1, -6, +4. You can use a calculator. Noah, go ahead. Oh, I thought you had it. That's why I called it. You have it? -3x. Yeah. -3x. Remember, because it's negative, I have to put that minus sign out there. Last one. -3x squared plus 2x squared plus 1x squared. What do you think, Ashton? -3 plus 2 plus 1. 0. 0x squared. So we don't even write it, correct? So this is our final answer. -3x minus 7. -3x minus 7. Okay. Number 5 is also a subtraction and addition. Whenever I have a subtraction and an addition mixed together in my polynomial operations, I always change the sign of the subtraction one and I put it first. It's just kind of how my brain works. I'm going to do this one horizontally because I think some of you like the horizontal method versus the vertical, so that way you can see it. So I'm just writing this term first. A negative times 2a squared is a negative 2a squared, absolutely. A negative times 2ab is perfect. A negative times a -5 is a +5. And then to that, I'm going to add positive 3a squared minus 1ab. I'm going to put a 1 in front of that just so you can see what's going on, plus 4. And I'm also going to add the last polynomial, 5a squared plus 2ab plus 6. Okay, so the first thing I'm going to do is kind of identify my like terms. I'm going to identify all of the a squared terms. So let's see, I have a -2a squared, a positive 3a squared, and a positive 5. So really, I think of it as 3 plus 5 is 8, minus 2 is 6. So I have 6a squared. Now I'm going to focus on my AB terms. I have a -2ab, a -1ab, and a positive 2ab. What do you get? Yeah, it's -1ab. Do you guys see that this positive 2ab and -2ab cancel each other out? So you just have -1ab. I always look for terms that cancel each other out. That makes our math a little bit easier, right? Our last one is going to be the constants. So I have positive 5, positive 4, and positive 6. When I add multiple constants, multiple numbers together, I always try to match up pairs of 10s. I know 6 plus 4 is 10, plus 5 more is 15. So my simplified polynomial in standard form, 6a squared minus 1ab plus 15. 6a squared minus 1ab plus 15. Questions? Do you guys feel okay with that? What do you mean 1 by 1? Take the 3 minus the 2, yeah, and then take what's left over and add it again. You don't have to do it all at once, yeah? As long as you remember to distribute your negative, right, Aiden? Absolutely. You don't have to do, you can do 2 terms at a time, 2 polynomials at a time. Is that what you're saying? Yeah, absolutely. Question number 6 asks us to find the perimeter. Find the perimeter of the rectangle. I am not really sure how to do perimeter. Someone tell me about that. Violet. Add up all the sides. What about the sides that don't have anything written on them? The same as what? So the number on the top is the same as the bottom. Okay. Why is that? Because they're rectangles, right? Opposite sides are congruent. And so if the left side is 2x plus 1, the right side is 2x plus 1. So we have to add up all the like terms. Add up all of the like terms. Well, let's see. My x squareds, I have a 3x squared plus a 3x squared. Do we want to write this one out? Do you guys want me to expand it, write it out so you can see what's happening? So let's see. I have 3x squared minus 2x plus 5. And right below it, I'm going to write plus 3x squared minus 2x plus 5. Do you want me to keep going, or do you want to just chunk this one together and then do the other sides? Okay, so let's add these two together. So this is the top and the bottom. 3x squared plus 3x squared is 6x squared. Negative 2x and negative 2x is negative 4x. Good job. Positive 5 and positive 5 is 10. Okay. Now I'm going to do the left side and the right side. So I have 2x plus 1 added to 2x plus 1. Okay. So 2x plus 2x is, and 1 plus 1 is. And since I'm finding the perimeter, can't I just add these two polynomials together? Okay, so I don't have any 6x squared term in the second polynomial. So I know that when I add these together, I'm going to get 6x squared. My x terms, I have a negative 4x and a positive 4x. What does that do? Cancel out. I have a constant positive 10, constant positive 2. 10 plus 2 is 12. So my perimeter, I'm going to write capital P equals, I'm going to put this in a parenthesis, 6x squared plus 12. And right after it, I'm going to write the word units. Right after that, I'm going to write the word units. Okay. Because remember that perimeter is actually a measure. We don't know what the units are, but if we could figure out the value of x, or if we were given the x, we would actually be able to calculate the units. Okay. Number 7, I screenshot these. I don't know if you guys can tell. This is a screenshot. So when I screenshot my triangle, because of the weird angle, you didn't get the bottom measurement, and I couldn't fix it because it was a picture. It wouldn't let me change that measure. So I want you to know that this bottom measurement is 6x minus y. That bottom measure is 6x minus y. And I want the perimeter of this one as well. We're going to find the perimeter. So do you guys want to stack these on top of each other? Do you want to do it horizontally? What are you thinking? Stack them up. Okay. I'm going to start with this side. 4x plus 3y. I'm going to go to the short side. Plus x, and I'm going to put a 1 in front of it because I think that helps us. 1x plus 3y, and then the last side, 6x minus y. All right. So 4 plus 1 plus 6 is 11. I have 11x. 3 plus 3 minus 1 is positive 5y. So my perimeter, capital P, equals, I'm going to put a grouping symbol around these, 11x plus 5y, and then I'm going to write the word units after it. 11x plus 5y units. Okay, because I want to remember to do that. Our last two examples, I left space so we could do those vertically. We can do them however you want. Maybe we do the first one using Aiden's idea of just adding two things at a time. And then the second one we'll do however you guys want. So let's look at this first one. So Aiden said, can't you just add them a couple at a time? And this is what Aiden meant. Like, can't we just do these two first? Yes, Aiden, is that what you were talking about? Okay. So let's just focus on these two. Is there an x cubed term in this polynomial? In this polynomial? In this little one on the end, the 7 minus 4x. Nope. So I'm going to have 5x cubed. That's going to stay there. 5x cubed. Is there an x squared term in this polynomial over here? No. And that's a positive. So positive 2x squared. Then I see that I have a negative x and a negative 4x. A negative 1x and a negative 4x give me negative 5x. And what do I have left? Plus 7. And to that, I have to subtract this polynomial. So when I write it next to it, the first thing I'm going to do is make sure that I distribute the negative through all of them. Does that make sense? I'm going to take this negative. So negative times 6x squared is negative 6x squared or minus 6x squared. Yeah. And negative times a positive 5x cubed is a negative 5x cubed. So that makes that a minus. And this negative times my negative 3 gives me a positive 3. So let's start again with this 5x cubed. I have a positive 5x cubed. In the polynomial that we just added, do you see an x cubed term? Yeah, negative 5x cubed. What does positive 5x cubed and negative 5x cubed do? Yeah, they cancel each other out. So I'm just going to put a big old x through them. Okay. Let's see. Do we have an x squared term in the second polynomial that we just added on there? Yeah, so I have 2x squared minus 6x squared. What's 2 minus 6? Negative 4. 2 minus 6 is negative 4, so that gives me negative 4x squared. Now I'm going to look, do I have an x term? Do I have an x term in this second polynomial? No, so this negative 5x just comes down. It comes straight down. Minus 5x. Minus 5x. The last two terms that I have in common are the constants, a positive 7 and a positive 3. 7 plus 3 is 10 plus 10. And that's what this looks like. Negative 4x squared minus 5x plus 10. Hayden, go stand at the desk over there, the tall desk, with your notes. And keep your eyes open. Number 9. What do you want to do first? Bailey, what do you want to do first? Distribute this negative, okay? Distribute, distribute, distribute. So I'm going to rewrite the first polynomial and I'm not changing anything. Negative 2x cubed. Do you guys want to stack these up on top of each other or just keep them horizontal? What are you thinking? What are you thinking, Bailey? Do you like them stacked up or do you like them horizontal? Stacked? Okay. So let's see. I'm going to distribute this negative to the 3x. So that's going to become a negative 3x. Negative 3x goes right below the x term. Right below the x term. When I distribute this negative to the negative 4, let's see, a negative times a negative is a positive. So this positive 4 is going to get stacked up right below the other constant, 8. When I distribute this negative to the positive 2x cubed, that's going to give me a negative 2x cubed. That's going to go right below the other x cubed term. Remember that we're adding these because we've changed, gosh darn it, we've changed the subtraction to addition, right? So let's just add them up. Negative 2 and negative 2 gives me, they don't cancel out. If one was negative and one was positive, they would cancel out. They're both the same sign. Negative 2 and negative 2 gives me negative 4x cubed. Jaden, do you see that they're the same sign? Okay. That's okay. I don't have an x squared term, so I'm just going to kind of draw an arrow to tell myself, hey, just bring that straight down, plus 5x squared. I'm going to put a 1 in front of my negative x. So I have negative 1x and negative 3. Matthew, what's negative 1 and negative 3, please? Perfect. Negative 4x. Last one. Braden, positive 8 and positive 4 give me positive. Perfect. How do we feel about that? We like that? Okay. I want everyone on the right side of the room. So Caden's table, Bailey's table, Jansen, Travis, and Hayden. Guys, grab a dry erase board. Get up and grab a dry erase board and one of the erasers. Dry erase board and eraser.